In this video, we're going to do checkpoint 2 together. So this is just a little bit more, another example, I guess, of a word problem and how we set up the linear programming. I mean, really, linear programming is just the set of inequalities with this added piece that we have this objective function, right? So really, let's not overthink it and think linear programming is so hard. It really is just a system of inequalities with an extra objective function that we want to optimize. Okay, so let's read the checkpoint 2. So it's a popular cereal combines oats and corn. So that's kind of jumping out as my variables right there. It tells us that at least 27 tons of cereal are to be made. So that is giving us a constraint, right? We need at least 27 tons total. And for the best flavor, the amount of corn should be no more than twice the amount of oats. So again, that looks like another constraint here. And then oats cost $300 per ton, corn $200 per ton, and then we want to minimize cost, right? So this money piece, this is going to be part of our objective function. Okay, so let's read the directions. Part A, make a chart to organize the information that's given. So, okay, so for part A, we have two types of grains, oats and corn. And so here's a good place where we can sort of define our variables. We'll call the number of tons of oats, we can call that, let's say, X, and the number of tons of corn, we'll call that Y. Okay, and then we have a restriction here that we know that this has to be at least, right? At least, so greater than or equal to 27 when we make this into an inequality. And then we also have some information about the cost per ton, right? So this is going to be $300 for the oats and $200 for the corn. So there's our information. There's some information in a chart, but the one thing I'm noticing we're not really able to put in the chart is the second constraint, right? So I can talk about the sum here of X and Y has to be greater than or equal to 27, but for this flavor thing, so the amount of corn should be no more than twice the amount of oats. I just crossed through that, sorry. Right, so that's a constraint that I really can't put in my chart. So luckily, I mean, honestly, we don't even really need the chart. Okay, we could really just go right to parts B and C. We could write these the objective function and the inequalities, and it actually doesn't matter which order we do it, but they're asking for the objective function first. So the objective function, remember, is not going to be using, it's not going to be equal to X or Y or anything, but it is going to use X. So the cost will be, and I think the book has been using Z as the objective function, but it's going to be whatever 300 times X is plus 200 times Y, right? Because this is the cost per ton, and these are the number of tons. So this is our objective function. Okay, and then part C, to write the inequalities, now we use the fact that we know that the total number of tons has to be at least 27, so that has to be greater than or equal to 27. And then we also have this other one that isn't in the table. So for the best flavor, the amount of corn should be no more than, so when I read no more than, I can think of that as being the same thing as less than or equal to, right? So less than or equal to, because it's no more than twice the amount of oats. Okay, so the amount of corn, Y, has to be less than or equal to, or no more than, twice the amount of oats. And so there you go. There is my system of inequalities, but they did say 4, and of course we have to remember that of course these represent the number of tons of corn we're going to have, so these are of course also positive. So that'll give us our 4 inequalities.